Hello everyone, I'm going to be introducing myself with Snack Penguin because I'm going to be changing my YouTube name soon. I don't like Snack Penguin, it's my gaming name. Gaming name needs to go with gaming channel, and educational videos need to go with something else. Anyways, today I'm going to be going over the structure. The one example I'm going to be following is C2H2 and Br2. What I want you to have out right now, because you're watching a YouTube video, I'm assuming you're going to be on Google Chrome, is to go to ptable.com so that you can go on the periodic table. You know why? Because we need to find the least electronegativity between C2 and Br2. You know why? Because that's how we determine the skeleton structure. Alright, I'm assuming that you already found everything, so let's just get on to it. Alright, the basic way that you draw the Lewis structure is the least electronegativity goes in the middle, and then you branch from it. Alright? So, if you look at the periodic table, I will just give you a basic understanding of the trending for electronegativity on a periodic table. Basically, the more you go to the right, the higher your electronegativity is. The more you go top, the higher the electronegativity is. What's more important? Going to the right. Going to the right gives you more valence electrons. So going towards the right will have a significant impact on the electronegativity compared to going up. Now, from left to right, the one on the very left will be carbon, and you're going to be asking, Stank Penguin, why isn't hydrogen the least electronegative? Because it's not part of the non-metal. Well, it is a non-metal, but it's like all the way towards the left. It's like I'm just gonna draw the basic periodic table. It's so useless. No one cares about hydrogen. Hydrogen sucks. Okay, I'm just kidding on that part. Anyways, uh, anyway, since we know that carbon has the least electronegativity, it's gonna be going to the very front. Now, let me just delete all of this. I shouldn't have drawn it. Why did I draw it? I regret life. Anyways, carbon goes here. And the basic understanding you need to have in the structure is that it needs to be symmetrical. So what that means is you have carbon, then you have carbon. If you have hydrogen on one side, you also need to have a hydrogen on one side. If you have a bromine on one carbon, you also need bromine on the other carbon. It's completely symmetrical. That is very important when you're drawing the Lewis structure. Anyways, we need to count the total amounts of electron for every single one of them. I memorized bromine, carbon, and hydrogen because I'm so smart. So basically, hydrogen has 1 per mole. Carbon has 4. Bromine, my pronunciation is pretty bad, is 7. So there's 2 of carbon, so 8, 2 of hydrogen, so 2, and 14. So we have a total of 24 electrons, valence electrons. I'll be saying valence electrons so that you guys don't confuse yourself. Anyways, we have this. What we need to do is we need to split these 24 electrons equally amongst every single one of these atoms so that they can all be happy. What I mean by happy is happy means every atom has 8 valence electrons. Except there's one exception. It's hydrogen. Hydrogen only requires 1 since it's on the very left. I told you it's completely useless. Hydrogen requires only 2 valence electrons to be happy. I don't know why. And by 2, I mean just bonding 1. Hydrogen just gives away its like 1 electron and it will be happy. That's why it's completely useless. Anyways, so we need 8. And you see all these lines that I drew between hydrogen to carbon, carbon to bromine. These are called bonds. 1 bond means 2 valence electrons. Double bond means 4, and triple bond means 6. I think you have a basic idea of this. And so if you count, okay, let me go to the first step. If when we are drawing the Lewis structure, go with the single bond. Never go with double bond or triple bond, like at the very start. I'll show you why later on, but basically just go with single bond. Trust me on that one. And what we have is we have 5 single bonds, so that makes it 10 valence electrons. So 24 minus 10 will be 14, and we have 14 remaining. So let's just mark it in. 1, 2, 3, 4. I want you to notice that I'm not going to be touching hydrogen at all since it's already happy. What's not happy is carbon and bromine, since they need 8 valence electrons. Carbon only has 6. This one has 6. This one has 6. This one has 6. This one has 6. This one's only 2. This one only has 2. So we need to just fill it in. And it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We ran out. We need 2 more right around here. Actually, did I count it correctly? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I did not count it correctly. Why am I teaching you guys when I don't even know basic counting? Anyways, we need 1 more right here. Then what we need to do is we need to take out 1 set of electrons so that we can make it into a double bond and put it in bromine. That's why I'm telling you do not put a double bond or triple bond since the very beginning. It's because we need to have single bonds and see if it's necessary enough for us to put a double bond or not, or if it makes sense if we put a double bond or not. Anyways, we see a common trend. Carbon and carbon only needs 2. So we can take out 2 from above. And we can put a double bond between carbon and carbon. And that gives us 2 more. Since 1, 2, 3, 4, 5, 6. 6 means 12. We have 12 remaining. So we have 1, 2, 3, 4, 5, 6 on one side, 1, 2, 3, 4, 5, 6 on the other side, and bromine is happy because it have 8. Carbon, 1, 2, 3, 4, 8 valence electrons, it's also happy. Hydrogen, completely useless, no one cares about them, they're always happy. Anyways, this is the basic Lewis structure. No one saw that. I'll be cutting that out. Anyways, this is the basic Lewis structure for C2H2Br2. Thank you.